Hello, and welcome to Network Wednesday here on Answer Everywhere. Today we're looking at Wireshark, the popular or the world's most popular network protocol analyzer. That's their claim, at least on the site, and I think that's probably true. This is a live show. This is an improvised live show, and every day we take a look at a new source code repository. I'm not a big Wireshark user. I think I've started it a couple of times. And done a little tiny bit of analysis when to debug very simple issues. But my understanding is that among people who work in networky fields, this is an important and well-loved tool. So I figured we would take a look at it, since the theme of Network Wednesday is that we're looking at stuff that's used for the network. Okay, so here's their website. Looks nice, looks well branded. I'm actually just going to jump into their code, which they have a GitLab. And there's also a mirror on GitHub, which we may resort to if we run into any troubles with their GitLab. Somewhere I saw, maybe on Wikipedia, somewhere I saw what it was written in. So it says, Wikipedia says C, C++, and Lua. C and C++ are totally expected. Lua is usually used as an embedded scripting language. So maybe that's used for writing scripts to analyze. I don't know if the Lua interface is user visible, but we'll potentially see that. Actually, let's see if we get, let's see, Wireshark Lua script. Let's see if we can find anything about writing Lua scripts. Lightweight programming language. Yeah. For prototyping and scripting. Okay. Beware the GPL. All right. Lua can be used to write dissectors, post dissectors, and taps. I don't know what a tap is. Let's find out what a dissector is and what a tap is. Presumably, dissector is going to dissect or break apart packets into their component parts and look at them, but let's verify that. Dissectors are meant to analyze some part of a packet's data. They are similar to their older brothers written in C. Note that heuristic dissectors and post dissectors operate differently and are described separately. Okay, so they break packets up and look in their data. And these are Lua dissectors. And then Lua taps are a mechanism to fetch data from every frame. They can be defined to use a display filter. So here's a simple tap. We've got a counter, and our tap is tap HTTP. And at first we declare a new tap. Okay, this function will be called at the end 3 of the capture to print the summary function. Debug HTTP packets, HTTP packets. And then I guess we'll increment how many we've seen. And that seems like just like scripting. And then there's something about my tap menu. Okay. So the Lua is used for scripting. We'll black box that for now. Let's look at what we see in the code. So what we see, and this is common, I think, to a lot of maybe older projects, we see some C files in the main directory. Often for newer projects, a lot of the files are tucked away into a subdirectory. We also see the traditional metadata files like README. I guess GitLab doesn't let me highlight things the way that GitHub does. And then we have a bunch of folders like Wiretap, Wirecap, WSUtil, presumably Wireshark util, test, tools, plugin resources, plugins, packaging, include Fuzz, Fix, XCap, EPAN. I'm not sure what EPAN is. Some documentation stuff, CMake, build stuff, I guess, and capture. And I'm not sure what's most important. I guess I'll take a look at the test directory, at least quickly. And then let's see what we have in terms of the C files that are showing up in the root directory. We have main, CLI main. I guess we'll look at the main entry point just to see if it tells us anything about what other files we should be looking at. I don't know what manuf is. Manuf. Okay, we have a ring buffer. Rawshark. Let's look at Rawshark. I guess let's at least look at the ring buffer, and let's look at the shark D header. And maybe the shark D C file. And then the T shark. Okay. Rand packet, maybe some randomized packet stuff. Guess we'll look at merge cap. That might be interesting and or important. And did we look at xcap? I guess that'll be enough for now. And then let's see which of these directories we want to look at. UI, I guess we'll take a peek at. Wiretap. We might need to look at include because it might have the header files for some important stuff. I'm curious about Fuzz. I'm curious what's in fix, but those will probably, I'll just take a quick look and close them early. Xcap, I'm not sure. That could be fundamental, but I think we're looking at some other Xcap stuff, so we may come back to that. And capture seems probably pretty fundamental. And that should keep us busy for a while. Okay, so where are we here? We're in test. Lots of tests. That's good. Text. We see lots of Python, so I guess they're probably using Python as the framework to run and organize the tests. So we have sweet IO, sweet xcaps, sweet dissection, sweet decryption, sweet capture. Let's look at sweet capture. First question is, how big is it? So rather big. Certainly hundreds. What is this? 600? Okay. And we have a bunch of classes. And each class has a short function that's just going to call some other function. Check capture 10 packets self. Command is equal to command shark. Capture 10 packets from the network to a file using T-shark. So I'm not sure where check capture 10 packets is defined. Okay, so here's some of the definitions of the functions, I guess. So check capture 10 packets. I guess that's an implementation called check packets 10 captures real. It creates a traffic generator, or rather, it takes the traffic generator you passed in and I guess assigns it to start traffic and C filter. And then this looks like command line stuff. So I guess likely what it's doing is it's calling the Wireshark command line. Essentially Python is operating as a kind of shell to call to the command line. And then we have start traffic and stop traffic are presumably going to start and stop traffic. Here's traffic generator. The traffic generator factory, invoking it, returns a tuple of start func and C filter, where C filter is a capture filter to match the generated traffic. Start func can be invoked by to start generating traffic, and returns a function which can be used to stop traffic generation early. Currently generates a bunch of UDP traffic to localhost. Okay, so through tests, I guess I'll, at least by default, or at least in this file, generate UDP. Okay, so let's see. So we have start press. Okay, let's see if we can find start traffic. Okay, so start traffic is returned by traffic generator. Where is it called? And then stop traffic is in red. I don't know how something gets to be red. Is that just a function? Yeah, I guess maybe just function calls are in red in this scheme. Okay, so that's just an example of a test. Here's the CLI main. We expect it's a main entry point, so we expect it to do things like parse command lines, and then mostly get out command line arguments, and then mostly get out of the way. We get so there's some out of memory error that we check for first. What do? We malloc some stuff. I guess we malloc the arguments. We call real main. The original main routine was renamed to real main via a macro in CLI main.h file, since either main or wmain can be defined on Windows, but not both. Okay, so that's some workaround for Windows. Let's see if we can look at the header file. I believe it was just called main.h. And yeah, okay, so if Win32, we have real main, And then what if not Win32? We're going to define main to be real main. Otherwise what? What is real main? I'm not sure what the other real main is. Is this just on Win32? If def Win32. Okay. I'm not sure what we do if we're not on Windows, but I guess we just have some other main somewhere. Oh, this is int win main, w main. We have a main. I think there was another main looking file in the root directory. Yeah, I'm not sure. Let's move along. Okay, so here's Rawshark. Rawshark, raw field extractor by Gerald Combs and Loris Dejani, based on T-Shark by Gilbert Ramirez and Guy Harris. Was T-Shark a separate project? See if Wikipedia knows about T-Shark. There's also a terminal-based non-GUI version called. Okay, so T-Shark is the I guess command line version. So what are we going to import? Some standard stuff, some Windows specific stuff, error codes, command arguments, file systems, sockets from WSUtil, privileges from WSUtil, logging from WSUtil, and I guess globals. Yeah. Capture UI utils if we have libpcap. So we saw libpcap when we looked at TCP dump. Libpcap is the library underneath TCP dump that actually handled capture things. Oh, Tat says hello, Tat. I can pop this window over here, or I might have to move it around. Let me move this out for now, and then I'll bring it back as needed. Okay. All right. We've got some enum, name, num, val, the numeric value. Oops. We've got some enum, the name, num, val, string value. Okay. Some string formatting stuff. Defining a bunch of filters. And then print usage. I guess this is like a help function. Like if you call Wireshark and ask for help, it'll print that thing. And then open a pipe for raw input. This is a stripped down version of pcap loop.c cap pipe open live. So there's a stripped down version of some pcap function. We check if pipe name is hyphen, I guess, standard in or a FIFO, and open it. And we're passing in the name of the pipe or FIFO and a POSIX file descriptor on success or -1 on failure. Okay, so we're going to try to open this pipe and do some branching for Win32, do some logging. We're going to check here, we're going to string compare the pipe name to dash. And if it's dash, we're going to set mode to 0. Maybe 0 is the thing for standard in. This is needed to set the standard in pipe into binary mode. Otherwise, CR and LF are mangled. I think CR and LF are carriage return and line feed, kind of two ways of doing new lines. And then we do more Windows stuff. And maybe more Windows stuff. Wait for the pipe to appear. While we're going to wait for some stuff. So hpipe is going to try to create a file with the pipe name. Do some error handling. And wait for named pipe. And open OSF handle. I guess open the file handle with the thing that we created. And then error out if we need to error out. And if we don't need to error error out, we're going to return the file handle, I guess. G boolean. So set link type is going to return a G boolean. I don't know what G boolean must be, some sort of customized boolean. Parse a link type argument of the form ncap, pcap link type, or proto blah blah. Pcap link type must be a name conforming to pcap data link name to val, or an integer. The integer should be link type value supported by Wiretap. Cool. All right. And then here's main. I guess here's regular main. And what is main going to do? We're going to have some error message and some whatever int is, some opts, I guess. And a bunch of G cars, whatever these G things are, I guess they have some sort of customized types. But we have pipe names, filters, prefs, probably preferences, disp fields, I guess fields to display. FC, I don't know, but maybe some kind of int, guint, guint. Okay, G unsigned integer probably. Skip pcap headers is false. And yeah, stuff like that. Report message routines, report blah, blah, blah. Okay, so, and let's see, we have some timestamping and, oh, so main's got some stuff in it. If we're in Win32, we're going to create an app running mutex. I don't know if we have any mutexes if we're not in Win32. Get credential information by calling init process policies. We're going to clear the filter arrays by calling memset and setting things to 0 as well. Initialize string format. G pointer array new. Maybe this is the format for printing things out. Attempt to get the path name. And then this is nicely commented about what they're doing. So is this necessary given that we're not reading a regular capture file? We're reading Rawshark's packet string format? If it is not. If it is, note that libwiretap must be initialized before libwireshark is. So that dissection time handlers for file type dependent blocks can register using a file type / subtype value for the file type. So I guess this is initializing wtap or maybe wiretap. Okay. Now we're going to parse args and do some stuff. So I'm going to actually skip most of the rest of this main. Here's raw pipe read. I guess let's look at read data from the pipe. So we just create some structs for the mem header and the disk header. And these are the mem headers has type, like, I guess, pcap packet header, and then pcap prec header. I don't know what prec is. Pcap rec header. I still don't know what rec is for the disk header. And presumably we're just going to call out to pcap. Want pcap packet header by decided. So create some like a place to store stuff, I guess. Newer versions of the VC runtime do parameter validation. All right, something about Windows, and then we've got this logic that's copied from capture loop.c. While we need bytes, while bytes needed is bigger than 0, we're going to call WS read, probably Wireshark read, on the file descriptor. Pointer to something, and bytes needed, presumably a pointer to the buffer where we're going to read the packets to. And then we'll check if we are done with our bytes, in which case we'll return false. And if we've led fewer than 0 bytes, I guess in an error condition, we're going to set the error to something non-zero and return false. Otherwise, bytes needed is going to be decremented by the bytes we read. And then data offset, we're going to, I guess, the buffer offset probably is going to be incremented by bytes read, because we're going to be reading, next time we do this, we're going to be reading further into the buffer. Okay, that all seems sensible. And okay, so whatever rec type is, maybe record type, we're going to set it to whatever rec type packet is. And if we want pcap packet header, we'll do some more stuff. calling. We don't seem to be calling out anything. We're just assigning some stuff with, I guess, fields from mem header for the most part. Otherwise, we use the disk header. All right. Then we're going to print some stuff if 0. I don't know what if 0 is doing. Yeah. And then load cap file. So we can load some file. Okay, so that's giving me a sense of what's going on. But one of the things that seems like is going on is we imported something here. Was it utils? WS util. So let's take a look at WS util. So here's where am I? I'm not in WS util yet, but here's WS util. All right, we get things like codecs, CPU info, whatever CRC is, maybe the error checking code. Let's see what CRC8 is, just to pick on one. Declaration of CRC8 routine in tables. Let's find out if we can find out what CRC is. Cyclic redundancy check. I don't know what. Maybe like an 8-bit check. Here's some CRC lookup table. Okay, so different kinds of checks. Maybe all from the same standard or maybe from different standards. Okay. The most commonly used polynomial lengths are 9 bits, CRC8, 17 bits, CRC16, 33 bits, CRC32, and 65 bits, CRC64. We're going to get some generator polynomial. It's the most important part of implementing the CRC algorithm. Wonder, is this a polynomial over like a finite field? Yeah, like GF2. Okay. So mathematical analysis of this division-like process reveals how to select a divisor that guarantees good error detection properties. In this analysis, the digits of the bit strings are taken as the digits of the bit strings, okay, are taken as the coefficients of a polynomial in some variable x. Coefficients that are elements of the finite field GF2, the integers modulo 2. Instead of more familiar numbers, the set of binary polynomials is a mathematical ring. Yeah, that's true. So whatever we're doing, we've got this polynomial over the field of two elements, and we're doing like polynomial arithmetic on it. Okay, so it satisfies a relation similar to that of a linear function, or more accurately, an affine function. So CRC of x O plus y is equal to CRC of x O plus CRC y of y O plus c. Where c depends on the length of x and y. And this can be stated as follows. Where x, y, and z have the same length, I guess we get the CRC z at the end. Okay, so I'm not sure exactly what they're up to, but that's kind of like standard, maybe like, I guess, information theory type stuff, you would call it. Codes. All right. At any rate, so we've got error, kind of like error detection codes, codecs, which should be encoding and decoding of some sort, crash info. But I think what I wanted was sockets. I'm just curious to see what they're doing with sockets. We have RSA, which is the clicking behavior behaves differently than on GitHub. So I guess I keep opening things and I don't mean to. Let's look at WS pipe, and I don't know what XT is. I thought I saw some socket stuff. Socket.c and socket.h. Let's look at those for sure. And then just for fun, let's look at privileges. We look at processes. Hey, do Bitcoin. Hi, Islam Ahmed. Yes, I will do Bitcoin. I don't think so. Somebody asked me on a comment to do Bitcoin, and I said yes. It's not scheduled yet. Um, the plan is to do, instead of doing like Bitcoin Core at head or at whatever is master or main, I'm going to do the original Satoshi code, assuming that I can find it. So that will be at some point, but I don't know when. But I will definitely do that. Okay, so let's look at some of this stuff. So WS pipe is routines for handling pipes. I don't think I know much about pipes. I know they're like a Unix thing, but presumably also a Windows thing. So the WS pipe type has a PID. Okay, PID should be process ID. And then we've got channels for standard in, standard out, and standard error. And then spawn sync. Run a process using gspawn sync on Unix and Linux and create process on Windows. Wait for it to finish. Okay, so this is some, we're going to spawn something synchronously and wait for it, I guess. We can initialize the pipe by passing in a pointer, check whether the pipe is valid. You can wait for the pipe. Okay, that seems good. I'm not going to look, I guess, at the implementation of pipes. You're welcome. I think that'll be a fun one. I think that code should be out there. I'm not 100% positive, but I'm like 95% positive that the original code is out there. Okay, here's socket.h. Yeah. So copyright 2016. And then also copyright 1998. Okay. So we're checking if we're in Windows again. Unix or Windows? Why is Unix a star? Pretending to be Unix with the aid of Cygwin. Okay. So initialize sockets, WS initial sockets, clean up sockets, socket P2OA. What is that? Something pointer to integer or something? Convert the strings of IPv4 addresses port or IPv6 address port to a socket adder object. Ports are optional. Receives default port and host byte order. All right, cool. So did I open the C file? Yeah, let's look at the C file. All right, so they're including socket.h, which is just the header from here. What else do they include? INET address. And nothing else really. What do they include in the header? Wireshark, some Windows stuff like WinSock. They've got this extern C thing. If def C++. Okay, so if we're calling from C++, I guess we're gonna, this must be a pure C stuff, so we're gonna say that it's extern C. But what do we import in the case of Windows? Where's Unix? If we have unist H, we're gonna get unist D. Otherwise, I guess we include sys/socket.h. Maybe that's the Linux include. All right. So init sockets, we initialize stuff for error messages, word, version requested, and WSA data. I don't know what those are, but that seems to be something Windows are doing. Wait, if we're not in Windows, am I reading this right? We're just going to set error message to null and return error message. Otherwise, we have to do some stuff for Windows. I guess this is kind of like a null op for Linux. Is that right? And this all seems to have like these Windows guards. Okay. So if we need to clean up sockets, we're in Win32, we're gonna call WSA cleanup. Otherwise, regardless of whether we're in Windows, the WS socket P2OA it has a real implementation. So we're gonna get a socket address storage, which is the destination, I guess. We're also going to take the source and a def port, and we're just going to manipulate some stuff around. Okay, so this utility is not really doing much actually with sockets. We see, what are these called? Classes, like traffic classes or something. AF INET should be, I think, just internet. We ran into that in the TCP video. And we have, or we might be INET6 if we're using IPv6 addresses. Yeah, okay, here we go. So IPv6 addresses are surrounded by these square brackets, right? Because things are separated by colons. And I think I remember reading somewhere that the concern was with the colons that if you popped them into like a URL, like if I, instead of gitlab.com, I popped in whatever the IPv6 address for gitlab.com was. Since colons are meaningful in the URL spec, like here, I'm trying to highlight that colon, that would be confusing. And so to get around that, we have square brackets for the IPv6 addresses. So what this function is, among other things, doing is it's going to look to see if there's a square bracket, in which case I guess we're going to assume that we're in IPv6. We'll move the pointer or whatever one character up, presumably, to kind of consume the square bracket. Dirchar string character so if the next character is a when we compare the next character to the right square bracket, if that's null, then I guess we have just a pair of square brackets that is kind of like an empty list and not an actual address. Otherwise, we'll increment p and set it to the null character or something. I don't know what this is really doing. But then we're going to set star p to colon. Set the port string to p+1. And then check whether we're at the end. And then call ws inet pton6. I guess this is maybe the function that actually understands IPv6 addresses. And we'll set the AF variable, like the traffic class. I forget exactly what these are called, but this thing is like the first argument into the socket that says we're doing IPv6. Otherwise, we try to do IPv4. Otherwise, we go to error. Okay, and then this else thing says like we don't have a bracket IP address, so we're using dotted decimal notation. So that's like 127.0.0.1 or whatever, and so that we have dots instead of colons. Okay, so there's not a lot there. They're not really dealing too much directly with the sockets, it seems like. Here's privileges. So we have init process policies called when the program starts to enable security features and save whatever credential information we'll need later. I don't know where they get credentials. Started with special privileges. I guess that's like root. Running with special privileges, relinquish special privileges permanently relinquish special privileges. Get credential info must be called before calling this. Get current username and get current group name. So I guess they must do something like check if they're running as root, and then if you are running as root, it seems like maybe they try to downscope if they can. Just out of curiosity, did I open the C file? I'm curious where they get the privileges, and maybe they're just from the OS. Like I don't think that they have their own privilege system necessarily. Init process privileges. Set process DEP policy. If we have set process DEP policy, turn data execution prevention on. Okay, that is, if the MMU lets you execute permissions on a per page basis, turn execute permission off on most data pages. Set process DEP policy fails on 64-bit Windows. It's always on there. But if it fails, we don't care. We did our best, so we don't check for errors. Okay. Starting with special privileges is set to false. For now, we say that the program wasn't started with special privileges. There are many ways of running programs with credentials other than those for the session in which it's run, but I don't know whether that'd be done with Wireshark, T-Shark or not. Okay. Similarly, running with special privileges is set to false. Username, I guess we're going to call G stirred up unknown. Return username. Okay. And then init policies is going to get, just get stuff from the OS. And then say that we've called this. Okay. What is this G stuff though? So we're including glib. .h. Is that like glib c? Is that like is G for GNU? I'm gonna guess that this is just the GNU lib, yeah. Written in, oh, by GNOME, okay, or GNOME, however you pronounce it. glib's code was separated from GTK, so it can be used by software other than GNOME. Okay, so I guess this is they must use GNOME for their UI. Let's see if we can figure out how to pronounce GNOME if we're using their toolkit. Since GNU is GNOME's first name, GNOME is officially pronounced GNOME. Okay, we'll call it GNOME. All right, so here we are in ring buffer. Got ring number unlimited files, min num files, ring buffer max num files is, what is this, 100,000? 100,000? Ring buffer warn, 65535. That's a, isn't that like one off from a power of 2, I guess, for fat? Just for fun, just for education. Let's look up this number. The integer after 6534 and before 65536. Thank you, Wikipedia. It's the product of the first 4 format primes. Format? Yeah, that's cool. It's the sum of 2 to the 0 through 2 to the 15. Yeah, cool. Is therefore a rep digit in base 2, all 1s, and in base 4, all 3s, and in base 16, FFFF. And it's the 15th 626 gonal number. The 5th, all right, some stuff. Okay, it occurs frequently in the field of computing because it's 2 to the 16 minus 1. Yeah, 1 less than 2. Yeah, okay. So I guess FAT must have used 2 to the 16th, I guess they used 16-bit numbers for file descriptors or something. At any rate, we can initialize a ring buffer, ring buff current file name, ring buff free. I'm not sure what's the value of using a ring buffer for file names. I don't think the C file will necessarily tell us, but maybe it will. There's lots of good comments in here. Definitions for capture ring buffer files. Oh, I guess if we're doing packet capture, right? So maybe the idea is that we can just keep writing to this file or to this buffer, and since it's a ring, like as we write more, it's going to kick stuff off the end, but it's not going to like overflow your memory because you keep capturing packets. You'll just lose access to stuff from before. Yeah, so this is some stuff about changes to here. Okay, so ring buff data, we've got files, num files, some file prefix stuff, file descriptor, current ring buffer file descriptor, DDH, an IO buffer, clean up old cap, ring buffer access. So maybe I'll just look up ring buffer. Maybe Wikipedia circular buffer will tell us when they're used. A circular buffer starts out empty and has a set length. Yeah. Right, and we're just going to go around the ring and stat stuff. Uses. The useful property of the circular buffer is that it does not need to have elements shuffled around when one is consumed. Okay, that's useful, so we don't need to move stuff around. If a non-circular buffer were used, it would be necessary to shift all elements when one is consumed. Okay, I guess so. Is well suited as a FIFO buffer, while a standard non-circular buffer is well suited as a LIFO buffer. Last in, first out. So yeah. Okay. Right, that's what I was thinking. So the first in, first out. I guess in the sense of like as you're writing stuff, the stuff that initially came in gets pushed off the top. Whereas a non-circular buffer, I guess it's easier to push the stuff off the back end because you can maybe decrement the pointer or whatever. some pointer that points to the end of the buffer. Okay. Makes good implementation strategy for a queue that has a fixed maximum size. Yeah. All queue operations are constant time. However, expanding a circular buffer requires shifting memory, which is comparatively costly. In some situations, overriding circular buffer can be used, for example, in multimedia. If the buffer is used as the bounded buffer in a producer-consumer problem, then it is probably desired for the producer, for example, an audio generator, to overwrite old data if the consumer, that is a sound card, is unable to momentarily keep up. Okay. So I'm not sure if they're overwriting, but maybe they're not. And maybe the idea of the ring is just to not have to reallocate stuff or whatever. Okay, so here's Shark D. I'm going to guess a Shark daemon. Network traffic. Yeah, okay, this is just a copyright statement. Oh, Shark D dissect. Maybe D is for dissect. So CF open, load cap file. I guess probably like a pcap file, or maybe it just means capture file. A Shark D dissect request. It's going to take a frame num, a frame ref num, a previous dissection num, a W tap, rec. I don't know what rec means. We've seen rec a lot. What could it mean? Received, recreational, buff, column info, C info, dissect flags, and some other stuff like a buffer. Oh, it's a Shark D dissect function. Maybe callback. Data. Okay. And then we can, I guess, do block might mean like blocking, as in synchronous. Then, okay, we do have a daemon. Okay, Shark D daemon. So we can initialize the daemon and, I guess, loop. All right. So some daemon, I guess, that we can send requests to get capture stuff from. Here's sharkd.c. This looks interesting. I'm curious about what the difference between looping the daemon and starting the daemon is. But maybe let's look at the main for the for Shark D. You've got this thing report message routines. Yeah. Init log stuff, noisily, I guess, say stuff. And then we're going to call init process policies relinquish special privileges. So downscope root. And then print the current user. So I guess we know who we're running as. Attempt to get the path name of the executable. Try to find, I guess, this is trying to find Shark D. How do we not know who we are? I don't know. Initialize version info. It's all just setup stuff. Set some timestamps. We're going to init wtap. Lib wiretap must be initialized before lib wireshark is, so that the section time handlers for file type dependent blocks can register using the file type / subtype value for the file type. And then we're going to register all dissectors. We must do this before checking for the -G flag. It's the -G flag dumps information registered by the dissectors. And then we're going to init codecs. Okay, and then init the cap file. Apply some preferences. And I guess call Shark D loop. And ret. Maybe that's the return value. And if this is a true loop, then if it's done and we've returned, then I guess the daemon has been exited. And once it's exited, we have this clean exit thing. Okay. Is there anything else? Let's look at process packet. Yeah. So we get a capture file, some dissect stuff, dissect type and offset. And if we're going to print packet information or we're going to read a filter or display filter, we're going to process taps. I don't know. We'll look up host name, set before dissect, epan dissect run. I'm not sure what epan is, but maybe epan is doing some of the work. Then if passed, frame data after dissect. Okay. And then we can load pcap file. Twitter source code analysis. I looked at the Twitter recommendation algorithm yesterday. The video is not up. I'm hoping to get that and a bunch of other stuff up today, if that's what you mean, Prakash. Here's T-Shark. We're going to ignore T-Shark. I'm going to try to get to some of the GUI code because it seems like what Wireshark is doing is mostly setting things up and then using other libraries such as libpcap to actually analyze the packets. But we will look quickly at merge cap just to see what its API is. I think I don't want to see the implementation. I think I want to just see the API. Merge cap.h does not exist on master. Well, I don't know what to tell you. Okay. Maybe I'll just see what, like, if there's a comment or whatever. So this is some usage. Merge. Okay, so it's like some function. Concatenate rather than merge files. Maybe this is for merging capture files. All right, merge cap. List capture types. List IDB. Merge callback. Some callback. Okay. I'm not sure, but what is xcap? I think we're in the header. Is xcap a library? Let's look up xcap. Xcap is a versatile plugin interface that allows external binaries to act as capture interfaces directly in Wireshark. So I guess we're going to call some external binary to act as a capture interface. It is used in scenarios where the source of the capture is not a traditional capture model, that is, for example, live capture from an interface, from a pipe, etc. The typical example is connecting esoteric hardware of some kind to the main Wireshark application. Okay, so now we've got some external binary that is going to emit some stream of packets, and xcap allows you to tap into that. That's cool. So here, let's look at UI. What is Wiretap? Wiretap actually looks kind of interesting. File wrappers, IP, IP trace, iSeries, log pcap. So just for the sake of time, we're going to ignore Wiretap, which might actually be interesting. So we may come back to it if we see it show up. Here's fuzzing. I assume that they're just fuzzing. I think these are probably just fuzzing tests. Get dissect handler. I'm not sure. A fuzzer variant of Wireshark for OSS Fuzz. See if you can find Fuzzshark. Fuzzy sharks. OSS Fuzzshark. Continuous fuzzing for open source software. So it's some Google thing, I guess. Fuzz testing is well known. Yeah. In cooperation with the Core Infrastructure Initiative and the Open SSF, OSS Fuzz aims to make common open source software more secure and stable by combining modern fuzzing techniques with scalable distributed execution. Projects that do not qualify for OSS Fuzz, for example, closed source, can run their own instance of Cluster Fuzz and Cluster Fuzz Lite. And we support a couple of fuzzers and some sanitizers and Cluster Fuzz. And we support some languages. I've never heard of this. Open Source Security Foundation. So this is cool, but I'll have to come back to it at some other time. So Cluster Fuzz. Scalable fuzzing infrastructure that finds security and stability issues in software. Okay, so somehow, I guess this Wireshark stuff is support for Cluster Fuzz. Seems to be like relatively recent commits. And here's Wireshark capture. Can I close this? So we're seeing I see a bunch of pcap stuff, whatever air pcap is, but I guess maybe pcap over Wi-Fi. iFace is like interface stuff. WS80211, I think that sounds like Wi-Fi. Look that up. IEEE 802.11, the Local Area Networks Technical Standards, and specifies the set of Media Access Control, MAC, and Physical Layer, PHY, protocols for implementing wireless local area network. Okay, so WLAN. All right, so what is AirCap? I'll just see if this is probably Wi-Fi stuff. AirCap H, okay. AirCap interface documentation. Describes the data structures and functions exported by the CACE Technologies AirPCAP library. AirPCAP provides low-level access to the AirPCAP driver. All right, so something, I don't know what CACE is. Let me look this up. AirPCAP software by CACE Technologies. Some USB adapter. It supports Wi-Fi. Okay. For both packet capture and active packet injection. All right. So I have some Wi-Fi capture stuff. All right. So I'm going to close capture. I'm going to close fix. So fix, we've got some XMLs. Does this just describe fixes? Field name, side, quantity type required, price type, transaction time, URL link, advertisement, execution report. I have no idea what this is. Booking unit, account type, working injector. This seems to be some sort of patch, maybe. So this is from quickfixengine.org. Look up quickfixengine.org. Look up, yeah, I guess so. It implements the fixed protocol for C++, .NET, Java, and Go. It's 100% free and open source with a liberal license. The Financial Information Exchange, okay, FIX protocol, is a message standard developed to facilitate the electronic exchange of information related to securities transactions. It's intended for use between trading partners wishing to automate communications. So this is some finance-y protocol stuff. And I guess that it's supported by Wiretap or Wireshark rather, so that if you are working in one of these places and want to debug stuff, it shows you maybe it interprets the bits in some relevant way, and somehow these define like what the fields are of so that things can be displayed. Okay, so we looked at Fuzzshark. And so here we are in UI, and I see Qt or Qt, although before I saw a bunch of stuff for GTK, so maybe they're not using, I don't know what they're doing. Maybe they use both. So let's look at capture.h. What else? Failure message is not so interesting. Maybe iFace lists. IO graph item sounds fun. Packet list utils. I'm not sure. Packet range maybe. Progress, recent, RTP media, RTP stream, simple dialog, software update, SSL key export, tap credentials. So these are just going to be different dialogues, I guess, in the UI. And just see VoIP calls. Louis maybe, or Lewis, maybe Louis. Asks if I tried something like SourceGraph for exploring. I have not. This sort of question has come up a few times. I'm going to look at the SourceGraph code, and I'm also going to look at a bunch of like LSP language server protocol repositories. And then once I do that, I'm going to move toward more of a model where we're using that. But to get started, and because like this is the view of code that kind of everyone who's watching has. I'm sure people can set up SourceGraph or clone into VS Code. But what we're going to do is like as we go, we're going to build build more tooling. So I haven't done that. I haven't done that yet, but that'll probably be, I think, the next few weeks. I think maybe next week is when I start looking at LSP stuff. But that's a good question. Okay, so here's the Qt stuff. Accordion frame. Some Bluetooth stuff. Capture file dot capture event. Let's look at capture event. I'm not really sure what I hope to see. Just kind of poking around. I don't think we need to look at a ton of cute stuff. So we're gonna what is this? Here's accordion frame. So we're gonna look at we're gonna import QFrame, and we've got a Q property animation. An accordion frame is the class, and there's not much here. Animated show, animated hide, visibility change. We can hide event and show event. We've got animation finished. Is the C file more interesting? Oh, we don't have it. Is there a CC file? Yeah, there's CPP is what they call it. Okay. We've got some duration. Maybe it's like the speed of the animation in some sense. Okay, so accordion frame, set style. So we've got some style sheet we'll set, which is kind of like CSS, probably some, I think, an XML style sheet if we're in Qt world. We can check if we're visible. Oh, if we are visible, we'll call show. I guess if we're not visible, we don't do anything. We'll check if display is remote. Okay. Animated hide. We'll hide stuff. Again, detect if display is remote. Huh. All right. So there's not a lot there. It's just kind of standard UI stuff. Here's capture event in Qt. And what do we have? Bunch of constants that are libpcap related. Capture updated fixed. We'll define some capture event stuff, taking a context and an event type. Also, we can optionally give it a string in a capture session. And we've got this capture context. Yeah, so not much here. Here's capture.h, but not in Qt. So I'm wondering if this is still Qt related or if we're in G land, GNOME land. So yeah, so we've got this gint. I don't think I've ever read a GTK file. So I'm not sure what I'm looking at, if this is one. We've got this, what? So, okay, this is defining a capture callback. I guess it's a thing that takes an event and a capture session and some user data and is void. We can add a callback, we can remove a callback, we can init capture input, we can start capture, we can stop capture, we can kill a child, which sounds very sad. And then we've got this pcap stuff and captures. Let's see if we can find, let's see if there's a CPP file. Negative. Is there a C file? There's a C file. Okay. So you're importing glib.h. And we get a lot more code. We've got this static glist, capture callbacks. So capture callback invoke is presumably just going to invoke the callback. Capture callback add, probably some data structure, right? GNU, some CB funct. Okay, so we're going to prepend into the glist of callbacks, whatever was passed in, and assign that to capture callbacks. So it's going to append, so prepend, I guess, to the front of the callback lists. They execute, I guess, in reverse order, you add them, like a push down stack, I suppose. I mean, if we start a capture, we'll set the state to capture preparing, set the count to 0, we'll emit some message saying that we are capturing. We're going to get the interface list string from the capture options, set a temp file, and we'll free the source string. Try to start the capture child process. So I guess we're going to, there's some child process. Which makes sense if we're in the, assuming that this is GUI code, and it seems like it probably is, although I don't really know GTK. But assuming this is GUI code, you don't want the capturing process to run on the UI thread, I guess. That would be the standard way to do a UI. So we'll try to sync pipe start with some stuff, and maybe this is the thing that starts the process. And if we failed to start the capture child, we, I guess, free, and we set the file to null, and we emit some error and return false. Okay, and then similar stuff for capture false, or capture stop rather. Interface lists, we've got a global interface list. We can fill it. We can scan the local interfaces. What does that do? Let's look what scanning the local interfaces does. Because I think we're still in UI, so this should be UI code. It should probably create some other process to scan. Scan local interfaces is just going to call scan local interfaces filtered. Fetch the list of local interfaces with capture interface list and the set of all interfaces in capture ops to include those interfaces. And then, okay, here's the implementation of scan local interfaces filtered. It's got some allowed types, an update callback. And we declare a bunch of stuff. And if we are running, we'll return scan local interfaces. Internally calls update CB, I guess update callback, to process UI events to avoid stuck UI while running possibly slow operations. A side effect of this is that new interface changes can be detected before completing the last one. This return avoids recursive scan local interfaces operation. So I guess you can call this maybe multiple times, and you don't want it to keep deeply nesting itself. So you just check whether it's already running, and if so, you just return, I guess. We're going to clear the list of known interfaces, retrieve list of information into IUpList. So we'll free some error info, and call capture interface list. And then for each discovered interface name, create a new device and add extra information like supported DLTs. So capture interface list, is this doing the work of actually enumerating interfaces? Yeah, this seems to be from some other file, which is fine. And so, okay, so we create a new device. I don't know what a device is, but we're going to use memset to zero some stuff out and then add some stuff, I guess, with various G strings. Cool. And if we have libpcap remote, we do some more stuff with like remote hosts. Okay. And we can hide interfaces. So I feel like I have a feel for what Wireshark is up to, and this is kind of what I expected it to be up to, more or less. Essentially, you know, it's a nice UI around stuff. I'm curious where like things like filters are defined in Lua. So let's see if we can find that. I'm going to just close everything else I have, and see if I can find where like what are filters, or presumably filters are maybe like libpcap filters that there's some UI interface for. And what was the other thing I just said? So filters and something. I don't remember. Oh, Lua. Yeah, okay. So let's see if I can search GitLab. So we have filter dialog, filter action, conversation filter. I still don't know what EPAN is. You see what if there's like a README in the EPAN directory. This looks interesting. Let's try Wikipedia. No. Enhanced Packet Analyzer. The following will give you a simplified overview of Wireshark's function blocks. Okay, so this looks nice. So we've got some machine with a CRT monitor. That's like the 1990s, I guess. There's some GUI, which is either Qt or GTK, which we found. And then it's got core, which is basically probably like a lot of the code that we've just been looking at. And then we've got capture stuff and wiretap. And I still don't really know what wiretap does, how it's different from capture. But we've got a dump capture engine in either WinPcap or libpcap. So ultimately, this is just like some interface to libpcap in Linux world, or then WinPcap is, I think, probably just like a libpcap for Windows. And here's where the capture filters are. They are like libpcap stuff, and then we get stuff from the network or from the bus. And then wiretap also like does stuff with the hard disk. Figure out what that is. And then EPAN is things like protocol tree, dissectors, dissector plugins, and display filters. And then we have utilities off to the side, disconnected from everything. Okay. So it seems like we should look at EPAN. And I'm just curious to at least know what sort of thing wiretap is. So EPAN, Enhanced Packet Analyzer. The packet analyzing engine. Source code can be found in the EPAN directory. Provides the following APIs: protocol tree, dissection information for an individual packet, dissectors, the various protocol dissectors, and EPAN dissectors, dissector plugins, and display filters. And wiretap is the wiretap library is used to read and write capture files in libpcap, pcapng, and many other file formats. Okay, so wiretap is really not that interesting, I guess, from a technical point of view. But it is part of, I think, what makes Wireshark nice. So let's look at EPAN, and then after EPAN, we'll call it a day. So here's EPAN, and I don't think I'm going to look super deeply, but like we'll pick a few victims and see just the flavor of what they're up to. So let's look at IPv4 and IPv6 headers. We have UDP or TCP. I guess maybe we're not at that level, huh? Here's TFS. I don't know what TFS is. Yeah. Anything else I recognize? UAT, TV buff, timestamp, TFS, tab, stats tree, probably string table, secrets. Oh, look at secrets. Register. Oh, Reed Solomon. Is that so that like we can verify the Reed Solomon codes in? I guess makes sense to verify, I suppose. I guess I'll look at proto, presumably for protocol. Plugin if, maybe plugin interface. And I guess let's look at the plugin interface.c file just in case that's where the interesting stuff. And I guess packet H and packet C. And IP proto. Maybe just the H file. So I'm not here till the end of time. Kind of curious what funnel is. And frame data, I'll look at HNC. Maybe filter expressions at H. What is expert? I'll get expert at H. Then EPAN dissect. And EPAN. And disabled proto. Okay, so I think this should be good. A good sampling. Oh, ASN1. I don't think that's interesting enough to look at. Maybe address and address resolve. And I'm going to actually look at these in reverse order. I don't think I can just reverse order my tabs, but I'll just go from the end. So address resolve. I'm in the header, right? Okay. So we've got some max length stuff. E address resolve struct. These are flags to control name resolution. So things like the MAC name, whether to resolve Ethernet MAC to manufacturer names. Huh. Okay. whether to resolve IPv4, v6, and IPX addresses into host names. We have the IP address, and we want to know whether to resolve it into a host name. So that's like a reverse lookup, I guess. Whether to resolve TCP, UDP, DCCP, and SCTP ports into service names. So maybe this is like, port 53 or whatever is DNS, and port 80 is HTTP or whatever. So some sort of reverse port lookup. Resolve addresses using captured DNS packets. Only load the host's file, blah, blah, blah. Okay. Some more stuff. We've got some serve port stuff. UDP, TCP name, and whatever numeric is. And a struct for a resolved name. Some, I guess, constants for if we've tried to resolve the address, name, resolved, static host name. And then we're in the header, so we don't get implementations, but we get like the API functions. So we can take the UDP port to display, returns the port name corresponding to that UDP port, or the port number as a string if not found. The more display port stuff, enterprises lookup, returns the private enterprise code string or unknown string. I don't know what private enterprise code is. Try serve name lookup, returns the well-known service name string. Okay, so if it's a well-known service, you can look up its name from, I guess, its port. Table name resolution. So it's all relevant resolve flags to false. Host name lookup process. If we're using C Aries process, outstanding host name lookups. Outstanding. This is called from a glib timeout in Wireshark and before processing each packet in Tshark. True if any objects have been resolved since the previous call. This can be used to trigger a display update. Okay. Get host name returns the host name, or this is, I guess, an IPv4 address if not found. Similar for IPv6. Okay. Anything else? Get hash, get edit resolve names. So it's a lot of like lookup functions. Let's see if we can figure out how they're doing get host name. Wait, get host. Oh, they're using maybe Aries. Get host by address. Host name lookup process. What does Aries do? For asynchronous name resolves. D library for asynchronous DNS requests, including name resolves. Okay. I guess we're going to just ask Aries to handle that. Here's address.h. So we're done with name resolution for now. Here's address.h. Types of global addresses Wireshark knows about. Address types can be added here if there are many dissectors that use them or just within a specific dissector. Then here's the these things. I think these are called maybe domains. And let's look up AFINet. These have some names, and I should tell people what they are. It's something family, and then I think the parameter in socket is called domain. Address family must be, right? So int domain, and then the domain argument specifies a communication domain. This selects the protocol family, which will be used. The formats currently understood by the Linux kernel include all this stuff. Is it also called address family? Yeah, so AF stands for address family, at least I think at least according to the Stack Overflow question. So that's good enough for me for now. Okay, so then we have a struct for address, as you might expect. Although why don't we use whatever is already provided? I don't know. So we can clear the address, set the address. Alloc address W memory. You can allocate addresses and stuff like that. We can copy addresses. So this is just this is not so interesting. This is just like working with address structs, and then having a nice interface so that the Wireshark people can program in a way that they like. Here's EPAN dissect. The section of a single byte array holds TV buff info as well as proto tree info. As long as the EPAN dissect type for a byte array is in existence, you must not free or move that byte array, as the structures that the EPAN dissect T contains might have pointers to addresses in your byte array. So how do you know that? This is, I guess, something that like garbage collection would know if you used a garbage collected language. But if we're in C, then maybe there's not a lot of facilities for knowing that. And maybe it's the caller's responsibility to figure that out. So the EPAN dissect has some session. A TV buff, I don't know what TV stands for, but buff is presumably some sort of buffer. T might be time. TV, no idea. So proto tree, I guess like a protocol tree and packet info. And there's not much to it. We just have this struct. There might be some stuff in the C file, I guess. Let's take a quick look. Oh, EPAN dissect doesn't exist. So maybe it is just a struct. So here's epan.h. We've got the dissect struct and some whatever defilter is. I don't know what D is. Packet provider data. So here's a big comment talking about the enhanced packet analyzer, aka the packet analyzing engine. Source code can be found in the EPAN directory. All right, this looks promising. Sections: air PCAP functions, air PCAP defs, and radio tap. So I guess this section is for air PCAP. Okay. So we can init air PCAP, init the whole EPAN module, load all settings, clean up, register a plugin, and you pass it in like a pointer to a plugin. What is this struct? Init, post init, dissect init, clean up. Okay, just some struct. EPAN plugins supported, which takes nothing and returns an int. And returns 0 if the plugins can be loaded for all of libwireshark, for example, tap, dissector, and EPAN. 1 if plugins are not supported by the platform, and -1 if plugins were disabled in the build configuration. So it's like a Boolean, but with a third value. All right. EPAN conversion init. Initialize the table of conversions. Conversions are identified by their endpoint. They are used for protocols such as IP, TCP, and UDP, where packets contain endpoint information but don't contain a single value indicating which flow the packet belongs. Indicating to which flow the packet belongs. Okay. So for things like IP and TCP and UDP, the packets contain endpoint information. There's no single value saying which flow they belong to. So maybe maybe they have, in some cases, like some indication of flow, but you have to maybe compute it. And why does the font change here? Is it because there's a single quote? I'm guessing that the single quote somehow makes whatever font syntax highlighting logic they're using confused. Because we somehow go from this kind of like gray off-white to like a more white. Okay, EPAN session. A client will create one EPAN T for an entire dissecting session. A single EPAN T will be used to analyze the entire sequence of packets sequentially in a single session. A session corresponds to a single packet trace file, okay? The reasons EPAN T exists is that some packets in some protocols cannot be decoded without knowledge of previous packets. That makes sense? So for example, maybe a trivial example, like if you have a TLS session, then you probably need to have watched the key exchange if you want to decrypt future packets. But there are probably other less trivial examples. This interpacket state is stored in EPAN T. Okay, so EPAN T is going to store some state that is the interpacket state, I guess the state that we need to understand further packets. All right. It's like a context. It's a context without which, in some cases, packet displaying or whatever would give you nonsense. And so we can do EPAN new, get modified block, get interface name, get description, get frame TS. TS must be some sort of timestamp, and then we can free and get version number. EPAN always visible, set always visible. Set unset the tree to always be visible when EPAN detect init is called. This state change sticks until cleared, rather than being done per function call. This is currently used when Lua scripts request all fields to be generated. So we get the first mention of Lua I think we've seen. Dissect fake protocols. Indicate whether we should fake protocols or not. I don't know what that means. We can also run a single packet dissection, and we give it a EPAN dissect T, EDT, file type, subtype, some wiretap stuff, presumably a TV buff, some frame data, and column info. And column info is probably maybe an out parameter, unless the first thing is the out parameter. In some code bases, the out parameter goes at the beginning. I think in other code bases it goes at the end, and then sometimes people just seem to put it wherever they want. But probably, I guess, maybe the beginning must be it. If we're getting it, this is a dissect type, and we're returning it the section essentially. Some stuff with, you can do more stuff with filters, compile info. Okay, I'm just curious about looking at the C. Okay, so there's some plugin stuff. Gcrypt logger. libgcrypt prints all log messages to standard error by default. This is noisier than we would like on Windows. Okay. So dissect init is just going to call some other function, right? EPAN star of data dissect init. I guess maybe whatever you passed in, we're viewing that as an EPAN plugin and calling dissect init on it as like an object. Register plugin just issues a warning. Okay, if we don't have support for plugins, then register plugin emits a warning. Otherwise, we just prepend the plugin to a list, which we saw before, that kind of prepend function thing. So here's init. We're gonna mostly just ignore this. Cleanup, we're gonna mostly ignore. EPAN session, we've got a packet provider, a pointer to a packet provider, and some packet functions. Get modified block. We're gonna, I guess, look into the session and get some modified block stuff. All right. Yeah, I'm just scrolling through, not really looking for anything. Just kind of like taking in the scenery. What is this fake thing that we saw? If EDT set fake protocols. Yeah. So I also don't know what tree is yet, but here we go. We have Lua. When we call EPAN dissect run, we're going to check if we have Lua. And there don't seem to be any obvious Lua arguments passed in the EPAN dissect run. But if we do have Lua, we're going to call WS Lua prime defaulter on EDT, done before entering WMEM scope. And that's all the Lua stuff we do here. And here's another example. If we have Lua, we're going to call WS Lua prime defaulter. Okay, so we're giving Lua some entry points, and I don't know how it's supposed to work. EPAN gather compile info has a bunch of Lua stuff. Or maybe for different protocols, LZ4, Z standard, maxmin DB, maxmind DB, new TLS. Maybe these are like Lua entry points for specific like functions. These don't seem to be quite protocols, but they are like functions or like programs, I guess. Okay, I'm just curious. So that's enough for now for that file. So let's see what expert is. I'm just curious what expert is supposed to be. Only for internal and display use. Expert field has EI and HF. Expert field info, which is set by the dissector, and then set by some register routines. Proto expert is exported from libwireshark.dll. We need a special declaration. Add an expert info. Add an expert info tree to a protocol item using a registered expert info item. I don't know. Maybe expert just means like advanced, like, extra information for. Maybe at some point in the code they decide whether like something that they're logging is for everybody, or if you only really want to look at it if you are an expert or something along those lines. Okay, so here we are in filter expressions. And a filter expression has a label, an expression, a comment, and whether it's enabled. But there's no like filter type. It's just a label, a string expression. Maybe the filter object is really the expression. Create a filter expression. So we're going to pass in a label, an expression, a comment, and enable. Okay. Expression, the display filter for the expression. The display filter. So I guess the display filter is maybe it's something like a regex that matches some set of packets. Let's see if we can find filter. So we're including, oh, this is just the header. We've got this filter expression type. Display filter. Yeah, I don't know. I don't know what a filter is supposed to be doing, but I think that it might be related to libpcap filters. Here's frame data. Compare timestamps. A packet whose time is a reference time is considered to have a lower timestamp than any frame with a non-reference time. In both packets' times, if both packets' times are reference times, we compare the times of the packets. I don't know what it means for something to have a reference time, but I guess some packets do. So packet reference time. Display time parameters and time references. So Wireshark is the first hit. The user can set time references to packets. A time reference is the starting point for all subsequent packet time calculations. It will be useful if you want to see the time values relative to a special packet. Okay, so maybe this is like, I want to debug, just use the TLS example. I want to debug some TCP connection or whatever, and I set the reference time to whenever like the handshake completes so that I know things like this packet came in 2 seconds after the handshake or whatever. I'm guessing that's what it's for. At any rate, we can do things like frame data init, frame data set before dissect. Okay. So here's more frame data stuff. I'm just going to kind of try to close things out. I don't know what a funnel is. I'm just curious what kind of thing it is. I see this seems to be a giant struct. Funnel ops, prepend text, set text, reload packets, set funnel ops. Entry point for Wireshark GUI to obtain all registered packet menus. Funnel register all packet menus. Entry point for Lua code to register a packet menu. Funnel register packet menu. But how do we know it's Lua? How is this different from the other one? I don't know. So we give it the packet menu item's name. Fields required to be present if the packet menu to be displayed. Function called when the menu is invoked. Callback data is Lua state for the callback function, because that's the Lua specific stuff, and it's a G pointer. Okay. We look at Wireshark funnel. Yeah, sure. I really just want to know about funnels though. Funnel action. You think this is actually going to mention funnels? No, of course not. Try Google. Let's try this funnel action thing. This is just a class reference. Document expired. Seems unlikely. Let's try Google. It's just linking to the source code. So I guess funnel is just whatever. Nobody knows what a funnel is. They just link to the source code. Okay, so here's IP proto. I'm going to guess this is the IP. You should try reading the C. Okay. Try reading CS related papers. All right. Thanks for the suggestion, Omega Lil. Here's the IP proto stuff. Declarations of IP protocol numbers and subroutines for converting IP protocol numbers into strings. Okay, so this is going to be a bunch of defines and some like utility methods. So we're going to ignore this. Here's packet.c. Let's look at packet.h actually, and ignore packet.c, I think. Okay, so we've got some nibble stuff. All right, that's exciting. So general, I guess this is probably the file level comment, packet, general packet dissection. So we can packet init, packet cache proto handles, packet cleanup. We've got the struct for dissector handle for dissectors you call directly or register with dissector add uint. The handle is opaque outside of packet.c. Here's a dissector that returns the amount of data in the protocol's PDU if it was able to dissect all the data, and 0 if the TV buff doesn't contain a PDU for that protocol. And then here, we change fonts again. Is there a single quote? I don't think there's a single quote in this line. There's a comma. This thing ends in a colon, but so does this. And somehow if is bolded. I don't know why. Is this my fault for having the dark reader thing on? No, it seems to be apparent in the default CSS. So I'm curious why it changes here. There's a comma here and a comma here. There's a single quote here and a single quote here. So maybe somehow it considers this to be a closed single quote, and then it doesn't know what to do here for the font highlighting logic. I don't know. Okay. At any rate, so this is not quite as white as the type information, although if is as white, and this color is the same as this, which is like this is the color of arguments to a function after a pointer, I guess. I don't know. Something's going on with the syntax highlighting here. Okay, at any rate, the negative of the amount of additional data needed if we need more data, for example, from a subsequent TCP segment to dissect the entire PDU. Okay. So we're returning the amount of data in the protocol's PDU. If we're able to dissect it, or 0 if it doesn't contain the info for that protocol. Otherwise, I guess the negative of the amount of additional data that we need. Why the negative? I don't know. Maybe it's just the easiest thing to compute and we want to be fast. Same with the dissector, but an extra parameter for a callback pointer. Here's a heuristic detector used in heuristic dissector add. Opaque, okay. Yeah, okay. So we're going to iterate over dissectors in a table, iterate over dissectors in a table with non-default decode and settings, and more iterating over dissectors. We're in packet. So in packet, we have like a table of dissectors. We have some collection of dissectors, and we can apply them. And this is where we're getting maybe an entry point to the dissector logic. So if I weren't an hour and a half in, this would be a good place to kind of focus my attention, or this or the C file. And in fact, this is the header file, and the header file itself is large. How large are we? Is this right? 885 lines, so nearly 900 lines. And let's see just how big the C file is. I think I had it open and closed it. Okay. Yeah, okay, so the C file is nearly is 3840 lines, so nearly 3,900. We might call it nearly 4,000 if we're feeling like rounding extra aggressively. So this is where a bunch of the stuff is. Okay, and so we're not gonna, I did two kind of long ones yesterday. So I'm reluctant to like make this one super long as well. But this is, I think, probably a bunch, maybe the heart of Wireshark in terms of like what it's actually doing to packets. But I will look at what it imports, which will tell us some stuff. So it imports a bunch of stuff from EPAN. This is presumably going to be like stuff like types that are manipulated and whose use really shows up in this file. But we get column info, exceptions, reassemble, stream, expert, prefs, and range, and some Wireshark utilities. So let's maybe see. We'll look at maybe a little bit of it. So here's the dissector table. We get a hash table indexed by port number. Let me increase this so maybe the font is more visible to viewers. Oops, that's maybe a bit much. Supplying a struct dtable entry if it records what dissector is assigned to that uint. All right, dissector handles is a list of all dissectors that could be used in that table. Okay, not all of them are necessarily in the table, as they may be for protocols that don't have a fixed uint value. Okay, so if UI name a type is a field for giving the width of the uint value for that dissector table. If it's a uint dissector table, a param is the base in which to display the uint value for that dissector table. The base, like a numerical base, and protocol is the protocol associated with it. Okay. So this is what the struct looks like. And I wanted to know, what was it? Let's see, like just maybe some of the expert logic. So we have expert packet init. We can clean up expert packet init. And is that all we do? 3 of 6 matches. Yeah, okay, so not much there. So if we had more time, or if you're really curious about like what Wireshark is up to, definitely check out epan/packet.c and the corresponding header file. But we're not doing that right now. Here's the plugin, I guess, interface, an API for Wireshark plugins. This enables Wireshark dissectors, especially those implemented by plugins, to register menu bar entries. So this is, I guess, mainly for GUI stuff, which will then call a predefined callback function for the dissector or a plugin. Also, it implements additional methods which allow plugins to interoperate with the main GUI. We've got a menu callback, some enum for menu stuff. Yeah. Toolbar stuff. And we can register a new main menu, set a parent for the menu. Okay. So this seems to be mostly GUI stuff. Toolbar, etc. Okay. I'm missing some chat stuff. Did I finish analysis on Bash? I guess I did an episode on Bash. Did I finish analysis? I don't think anything's ever like really finished. So, you know, for any of these things, you're not going to like finish anything on a first read through. But I did a first look through Bash. And so I'll leave it at that. And then Omegle said, I saw yesterday a production file of 17,000 lines C file. Yeah, that's a lot. Like I don't think there's really any harm to having like, I don't think there's any performance harm to that many lines, but you might, you know, if you're, you know, if you're running like, it probably takes a long time for GitHub or GitLab to serve that file. So if lots of developers are looking at that file, or if they're checking it out, that could be kind of a hassle. And also a file that long, it's kind of harder for humans to batch up and chunk in their memory something that long. So there are some downsides to files that long, but you do sometimes see, I think especially in C, you do sometimes see these like really long files where like a lot of the implementation happens to be there. And presumably they get that way by just accretion of, that's where the functionality was initially, and it kind of like snowballs as people add more stuff to make that particular part of the code base have more behavior. And you said I should try reading CS related papers. Do you mean like in this format, or do you mean like offline? I should try reading CS related papers. I definitely read CS related papers offline, but I haven't really considered reading other sorts of stuff like in this format. Occasionally I'll open something like a research paper. I think I did that in the Haskell, in a recent Haskell one, whatever the most recent one was. I think when I was looking at Twitter, I opened. I can't remember if I opened. Yeah, okay. So Twitter has some like publications I think that I opened, but I haven't tried like reading them, reading them live in public. Yeah, and it's for okay. Yeah, okay. So I'll consider that. Yeah, all right. That's interesting actually. I'll think about that. Okay. All right. So what is so proto is the protocol tree. I just want to know why this is a tree. Protocol tree related function. A protocol tree will hold all necessary data to display the whole dissected packet. Creating a protocol tree is done in two stages: a static part at program startup and a dynamic part when the dissection with the real packet data is done. Okay, the static information is provided by creating an HF register info HF array and register it using the proto register field array function. This is usually done at dissector registering, and the dynamic information is added to the protocol tree by calling one of the proto tree add functions. Why is it a tree though? Protocol tree? I mean, presumably it's got, presumably it's some sort of like recursive tree structure where you've got pointers to a thing of similar type or the same type. Make a custom format, but we're talking about arrays here, right? Where do we go? Array, and we're going to add bytes. So the reporting errors. Dissector assert, dissector assert. This is, I bet this is huge too. We're already 200 lines in and we're like still defining some like asserts. So this header, this is now a header that's 3397 or 3396 lines long. How big is the C file? All right, we're about 6,000 in and still loading from GitLab. Here we go. What did you say the other day? 17K lines. We're at 13K lines. Unless you don't want to count the editor stuff. So yeah, okay, still 13K. All right. Wild. So tree expanded set. We're gonna check if tree is expanded. So let's look at the header again. So this is presumably another file where if you are really curious about Wireshark, this would be where to go. But let's just search for tree. All right, protocol tree related functions. Oh, this is just the proto custom set proto tree. Set the column text for a custom column. So what are we going to get? We're going to pass in a tree. Oh, this is the header, so I'm not going to be able to see this logic. But do I get structs? Maybe let's look for structs. At the beginning. Oh, I think Firefox is still searching from the end. Let's try searching from the beginning. Struct expert field. Struct underscore protocol. And then we have this error reporting function that I think we saw. Encoding for time values. And this is a giant comment. Struct header field info. Information describing a header field. Okay, so this is underscore header field info. And one of the things it has is a header field info with no underscore. And this says same name next. Link to the next HF info with same abbreviations. And what else does it have? It has name, abbreviation, some strings, a bit mask, a blurb, a brief description of the field ID. So maybe it's a tree because it's pointing to the next packet. But why is it not a list? Here's some hfill thing, HF register info. Use field info, contains the field info for the proto item. Segment of split bytes, some flag stuff. One of these exists for the entire protocol tree. Each proto node in the protocol tree points to the same copy. We've got interesting H fields, whether it's visible, and then packet info. Here's a node, struct protonode. Okay, so this is the tree stuff. Each proto-tree, proto-item is one of these. We have protonode has subfields of protonodes, which are first child, last child, next, and parent. First child, last child, next, and parent. Is it so is it if it's like a like I don't know where the branching is, but maybe if the children are a list, then maybe the reason this is a tree structure is because we're pointing to different parts of the list. We're also pointing to our parent. And I don't know how so first child might be different from next because we're not we're not whatever the 0th child is. So I'm gonna maybe just guess. I don't know why I think this, but maybe maybe this is ultimately an array or a list. But the thing that makes it a tree is that we've got pointers to different parts of the array for kind of like optimization. Counting confidence is cheating. Yeah, well, that's true. Okay. I mean, so the comments do okay. So yeah, I think it would be good content. Omega Lil says, I think that would be good. CS is huge, so I have to think about like what area of CS is. And I'm also like not my academic background is not CS. So for papers that are for academically CS people, there might be a bunch of context that I don't have, and maybe I could learn that context publicly. But maybe I could also just try to rope in someone else as like a co-host who has like a PhD in computer science, and then like we could look through things together. That might be an interesting way of doing it. So I'll think about what sort of format that would make sense in. But I like that idea a lot. Yeah, so I still don't know what this tree is. Let's see if the internet knows. Whoops. I think it calls it a proto tree. Protocol tree. Yeah, I should have just looked this up. Well, no, I shouldn't have. I should say that like sometimes it's good to just look things up, but also like you also want to build your muscles of or at least I want to build your muscles of like trying to figure stuff out on your own. And so I kind of do back and forth. Like if I'm in a rush, I'll often look things up. But I also, if it seems like something I should be able to figure out, I try to see how far I can get without looking things up as well. But okay, so this is proto stuff. Why is it a tree? There's some subtree. You can add things to the subtree. I don't know. And maybe like I'm thinking of TCP, I guess, as maybe I'm thinking too much in a TCP case where there's like a packet ordering that makes sense, and maybe in other protocols, the ordering may not be linear, and maybe it's dissection stuff. Tree items represent information. In the packet details pane of Wireshark, the packet details view of Tshark, a tree item represents a node in the tree, which might also be a subtree and have a list of children. The children of a subtree have 0 or more siblings, which are other children of the same tree item tree subtree. The children of a subtree have 0 or more siblings, which are other children. During dissection, heuristic dissection, and post dissection, a root tree item is passed to dissectors as the third argument. Okay. In some cases, the tree is not truly added to in order to improve performance. Maybe the thing to do is to look up a Wireshark screenshot. And maybe just to see if we can get any add tree. Is this the sort of thing a tree is? You click on here and it's got children. That's certainly like a tree from a UI point of view. And yeah, I guess you would have multiple children, and those children can have children. Something like that. Yeah, I'll assume that that's the case. I still don't know. Yeah. Okay. Maybe I'll try it nested. Yeah, I'm just gonna guess that that's the sort of thing it is, and I'll move along. This is plugin stuff. I'll ignore that. We just looked at Proto. Why did they read Solomon coding? I don't know. Assuming this is Reed Solomon coding and not some other Reed Solomon thing. Global definitions for Reed Solomon encoder decoder. Bill Karn in 1996. Okay, but what are we going to do with it? We are going to encode Reed Solomon and erase decode RS. Erasures and errors decoding. The received block goes back into data. When do we call it? We'll GitLab search. Let me search that. Okay, well, we have it in Reed Solomon. All right, but where else? Yeah. I think Reed Solomon is also fields, right? Yeah, okay. GF 2 to the, this is probably notation meaning 2 to the M. But shouldn't it be called somewhere? Other than in the header and the, let's just grep encode RS, I guess. And what, recursive? Yeah. Do we import it anywhere? The editor config, and we make it. It might be dead code. I don't know. I mean, it's the sort of thing that's fun to implement, like finite fields. But it doesn't seem to be used anywhere as far as I know. Maybe you can like maybe it's there so that if you need to like on the command line or whatever, or in Lua, encode or decode some stuff. I'm not sure. So here's secrets, presumably something about TLS secrets. The interface is for management and processing of secrets provided by external sources like Wiretap, key files, HSMs, etc. Dissectors can register themselves as consumers of these secrets. So an HSM is a hardware security module that's like essentially a computer coded in epoxy or something, and then some of them will like self-destruct. So it's some computing device that contains secrets that is designed to be tamper resistant. They use them in like payment processing, like when you do your credit card stuff, or presumably Apple Pay or whoever, whatever. All of these digital payment things probably have a large number of HSMs somehow. And we can indent and clean up. And so this is going to be somehow a way to get secrets from these things, like key files. So like key file, I guess, would be like, if you want to Wireshark analyze your web server, then you presumably have access to your own TLS key, and you can use that to decrypt sessions and stuff. And presumably that's the sort of thing this is about. Future idea, provide helper functions to manage external files. Future idea, add a method for dissectors to mark secrets as in use, such that unused entries can be removed when saving the secrets to file. Intended use case, read large TLS key log file. Okay. Which is infrequently truncated by the user and store only the bare minimum of keys. So it does seem to be TLS related. All right, so here's IPv6.h. There's nothing interesting here. And here's IPv4.h. And there's nothing really interesting here. It's just a struct. Is there anything interesting in the implementation? No. Okay. All right, well, that was Wireshark. We found the EPAN, I think, is where the action is. If you want to know what what the Wireshark internals are doing, and like in terms of network analysis, it does seem like ultimately for capturing and filtering, they're using libpcap, which is the same stuff that underlies TCP dump, which we also looked at a few weeks ago, maybe about 2 weeks ago or last week. And then we also just looked at some of their GUI stuff because we just when we can, when we're looking at a GUI file, we'll poke around the GUI just to start getting a feel for how people code up GUIs in various languages. Like we've seen a few things that use Qt or Qt. I think this is the first thing we looked at that used GTK. But then we've also seen some stuff that does like HTML rendering or that sort of thing. So that'll be just one of the themes we return to because that's a big part of how source code works. So that's it for now for me. I'll try to get my backlog of videos up today. I'm reasonably optimistic that I'll get at least several of them up. And then tomorrow will be Thursday. That should be Theme Thursday. And I think we are looking at the theme has been Haskell build system. So I believe we're looking at the like Bazel bindings for Haskell that will let you build Haskell using the Google Bazel build system. So that's tomorrow. And then on Friday, I believe this Friday is a fan request Friday where we're looking at the Firefox kind of user interface source code, and most likely kind of like HTML rendering and stuff like that, rather than just like, how did the menus work, that sort of thing. So that's what's up for the rest of the week. Thanks, and thanks for watching.